Every single day, we log into dozens of websites and apps without a second thought. But have you ever stopped to wonder about the invisible process, that digital handshake that makes it all work? Well, that's web authentication. It's the silent guardian of our digital lives. So today, let's dive into how it all evolved. To even get why we need authentication in the first place, we have to start with a really simple question. Why does the internet seem to have a terrible memory? Why is it that every time you click a new link or hit refresh, the server treats you like it's never seen you before? Well, it all comes down to the web's fundamental rulebook, something called the HTTP protocol. And it was designed on purpose to be stateless. That means every single request you send is a brand new conversation. The server has total amnesia about your past clicks. Now, that's great for efficiency, but man, it's a huge problem if you want to create any kind of logged-in experience. So how did the pioneers of the web get around this? Well, their very first attempt was a system that was, let's just say, about as simple as its name sounds: basic authentication. The process was brutally simple. Your browser would make a request, and it would just staple your username and password right onto it. And this didn't just happen once when you logged in. Oh no, it happened with every single request. Every page, every image, every little piece of data, boom, username and password sent again. And you can probably guess, this was a terrible idea. Constantly broadcasting your credentials over the network was just asking for trouble, especially in the early days before encryption was everywhere. And on top of that, there wasn't really a concept of a session. You were either logged in and shouting your password, or you were logged out. There was no middle ground. The glaring flaws of basic auth meant developers had to get a lot smarter. And that's what led to a whole new approach, a new era we can kind of think of as the web's coat check era. This analogy is just perfect for understanding the next huge leap forward, which was server-side sessions. The idea was simple. Instead of handing over your most valuable possession, your password, every single time, you just get a temporary claim ticket. Okay, just picture this in the real world, right? You walk into a fancy event. You hand the attendant your coat. They take it, store it somewhere safe, and what do they give you back? A little paper ticket. That little ticket, it's worthless by itself. It's just a pointer, a claim check for your actual coat. So how does this translate to the tech? Well, it's almost the exact same idea. You log in with your credentials just one time. The server checks you out, creates a session for you, and stores that information in its own database. Then it hands your browser back a tiny, unique session ID. That's your ticket for the rest of your visit. And this was the huge breakthrough with sessions. By keeping all the important state on its side of the conversation, the server became the one and only source of truth. It put all the power, all the control right back on the server. And with all that control came a really, really important security feature: instant revocation. Think about it. If someone's account got hacked, an admin could just go into the server's database, find that user's session, and hit delete. And poof, just like that, the hacker's ticket is worthless. Access denied. Now, this system was a massive step up, and it worked beautifully for years. But as the internet started to explode from thousands of users to millions and then billions, that coat check room started getting really, really crowded. And under that immense pressure, the system started to show some serious cracks. The very thing that made sessions so secure, that centralized control, well, it turned out to be its biggest Achilles heel. Okay, so here's the problem. Every single time you clicked, the server had to take your ticket, run back to the database, and check if it was valid. At millions of requests per second, that database just gets hammered, right? It becomes a massive bottleneck. And what's even worse, if you had a big website with multiple servers, a ticket from server A meant nothing to server B. It led to all these complicated, messy workarounds just to keep things from falling apart. Clearly, the web needed a totally new way of thinking, something that didn't rely on one central brain. And that brings us to the modern era and the JSON Web Token, or JWT. Think of it less like a coat check ticket and more like a self-contained digital passport. So what exactly is a JWT? Well, instead of the server holding onto your info and just giving you a little reference number, it actually packages up your data, like your user ID and what you're allowed to do, into this small portable object. Then it cryptographically signs it to prove it's legit and just hands the whole thing back to you. Okay, so a JWT might look like a long string of random characters, but it's really 3 distinct parts, all separated by dots. The first part is the header. It's just metadata. It basically tells any server that receives it, hey, here's the cryptographic recipe I used to sign this thing. It's the instruction manual. The second part is the payload. This is where the good stuff lives. Your user ID, your role, maybe an expiration date for the token. But, and you have to get this is probably the most important thing to remember about JWTs, this data is not encrypted. It's just encoded, which means anyone who gets their hands on this token can easily read what's inside. So rule number 1, never ever put sensitive information in the payload. The real magic is in the third and final part, the signature. The server takes the header, the payload, and a super secret key that only it knows, and it uses all that to create this tamper-proof digital signature. If a bad guy tries to change even one letter in the payload, say, change their role to admin, the signature will no longer match. The server will know instantly that it's a fake and throw it out. And that's what guarantees the token hasn't been messed with. And this right here, this is the fundamental difference. With old school sessions, the server had to ask its database, hey, have I ever seen this ticket before? It's a lookup. With JWTs, the server just looks at the passport and asks a mathematical question. Does the math on the signature check out? It's pure cryptographic verification, which means no database call and way, way faster performance. So yeah, this whole stateless, math-based thing, it's incredibly fast, super scalable, but it creates one giant new headache, a problem that the old session system had totally solved. How do you get all that speed without giving up total control? This is what we call the revocation paradox. Once the server issues that JWT, that digital passport, it's out in the wild. It's valid until its built-in expiration date. The server has no way to reach out and cancel it early. Think about it. If someone steals that token, the attacker can just keep using it until it naturally times out. So how do we fix this? Well, most modern systems use this really clever hybrid approach. When you log in, you actually get 2 tokens. First, you get a short-lived access token. This is your stateless JWT, your passport. It's super fast, but it might only be valid for, say, 15 minutes. You also get a long-lived refresh token. Now, this one is stateful. The server does keep a record of it in the database, just like an old session ID. So when your speedy access token expires, you use your long-lived refresh token to securely ask for a new one. And since the server has a list of all valid refresh tokens, it can revoke one at any time, giving us the best of both worlds, speed and control. And that, really, is the tightrope walk of modern authentication. When you look back from just sending our passwords with every click to using coat check tickets and now to these sophisticated digital passports, the whole story has been about this constant trade-off. So the next time you tap that login button, just take a second to think about the incredible dance happening behind the scenes, always trying to perfectly balance the need for blistering speed with the absolute power of control.